Welcome to Scaling a SaaS Company for Public Company Readiness. I am Bedford Tucci. I'm an area sales leader at AWS. Today, I'm excited to intro John Hyman, co-founder and CTO of Braze, a comprehensive customer engagement platform that powers interactions between consumers and the brands they love. In his role as CTO, John leads the charge on building technical systems and infrastructure. Thank you so much for being here, John. I'll let you take it away.
Thanks so much, Beth. All right. Hey, everyone. It's so great to be here. Thanks for joining us today. It's really nice to be here together in person. So as Beth said, I'm John Hyman, co-founder and CTO of Braze. I'll quickly give you a description of what we do and talk to you about Braze. But before I do, I'm just kind of curious around the makeup of the audience today. How many of you are working at a public company? Okay, a good number of folks, so hopefully you're familiar with the processes I'm going to describe today. How many of you are working with a late-stage growth company? Not yet public, private? What about an early company? Early tech company, great, excellent. Well, the information I'm going to talk to you about today is important to learn about no matter what stage of company that you're in, because it really describes a lot of processes that really come about how to run a really solid, consistent, measurable engineering organization. So I first just want to talk to you a bit about what Braze does. Beth gave a really helpful overview. Is that our mission is to help consumer brands use data to deliver relevant and memorable customer experiences through personalized messaging. That means we help businesses send personalized emails, push notifications, in-app messages, text messages, and browser messages on the web, and more. Really, any interaction that a brand has with their consumers, we want to make sure that that message is relevant, it's friendly, it's timely, it adds value, and it strengthens that relationship between the consumers and the brands that they love. So we're an enterprise SaaS business, founded about 11 years ago. And we've got a number of different offices globally, but importantly, we've reached a lot of exciting scale in the digital world. Across our customer base, we help engage over 4.1 billion monthly active users. And last fiscal year, we sent approximately 1.5 trillion messages to consumers worldwide. We work with a lot of businesses that you probably interact with. We might be in your pocket or in your inbox. If you've ever, for example, signed up for HBO Max to watch House of the Dragon and started receiving emails about other shows or content to watch, that message is coming to you from Braze. If you got some exciting push notifications from Pizza Hut about their holiday specials on Cyber Monday today or Black Friday last week, those are coming to you from Braze. Or if you're going to do your taxes in a few months and you sign up for TurboTax and then get an email flow, push notifications, or other in-browser messages shepherding you through that user lifecycle, all of that messaging that you'll receive in a couple of months will be powered by Braze. Now, before I talk about public company readiness, I want to just start with an extremely high-level overview of the Braze services with an architecture diagram. And there's a reason that I wanted to toss this up here is because reliability is one of the key things that I'm going to talk about today. And it's important that you, in your journey to get to public company readiness, or if you're already a public company to continue to grow, scrutinize, debug, and optimize the entirety of your stack. So we work across a lot of different systems. We have over 10,000 servers that power Braze. We use database technologies such as MongoDB, Redis, PostgreSQL, AWS DynamoDB. We've got AWS Lambda in our stack. We've got tons of different technologies. And every single one of these things we've had to really scrutinize and make sure that we can scale and grow that. Doesn't matter if it's our network links, it's our instance types, it's the type of processors we use. By the time you get to achieving a lot of great scale, you will need to make sure that you have really interrogated all of your systems to make sure that they're built to grow multiple times from where you are today. So I mentioned that we have over 4.1 billion monthly active users. The way that we count those is if you use one of our customers' mobile applications or websites, you're a monthly active user. So if you've signed up for HBO Max and also for TurboTax and Pizza Hut and KFC, you could be 4 monthly active users to us. So because of that, we need to prepare for a world in which we have 5 billion, 10 billion, even 20 billion monthly active users. And so every time I think about scaling our systems, we're always asking ourselves, not just can this double from where we are today, but can we make sure that this is going to be able to 5x or 10x where we are today? At its foundation, whenever you're thinking about becoming a public company, you need to make sure that you build a scalable product, and we're happy that we build that on top of AWS. So I'll talk to you a bit with that background about what I mean by public company readiness. Now, ultimately what I mean here is a mindset that you can run a company in a way that's predictable and consistent, ensuring that your company can withstand the scrutiny and the processes of being a public organization in the public space. Now, public company readiness is a massive topic, and much of it is actually focused around accounting, finance, revenue recognition, financial audits, financial reporting. But still, there's a lot that you can do as an engineering organization or as an individual engineer or manager in your teams to set your company up for success here. And so I want to talk to you about the engineering point of view and perspective that we have to get to our public company readiness. And a bit for background here, this is a very long journey. At the end of 2018, we as a leadership team at Braze made the decision that that was when we were going to start our journey toward public company readiness. And we said that we would be ready by the end of 2019. And it actually took all the way until 2021 for us to get to where we felt that we could meet the strong demands of a public company. So it really is something that you should start early and make sure that you're building strong processes for. So these are the topics that I want to discuss today from the engineering point of view. And when we started that journey in 2018 and 2019, thinking about what we needed to do to become a public company, we started off asking all the different department heads what they thought they needed to do to withstand the scrutiny of the public markets. So I looked back on the topics that I thought about and that I wrote down, and I revisited them. And what I put was reliability, security, cost management, and team efficiency. So these are the focus areas that I thought we in engineering could contribute to the company on our path to being ready for being a public company. And readiness is just a very important part of this preparation, because if you're looking to go public, if you're a private company and that's your goal, you have to keep in mind that an IPO is a point in time. Ours happened last year, and we've continued to grow since then. And you have to continue to improve your processes and motivate your teams. And so we really think about being ready, not the actual event itself. Now, before I dive into those 4 topics, I wanted to share my vision for the Braze engineering organization. And I thought this would be particularly helpful for those of you who are engineering leaders in the room, because you need to make sure that you have a vision for your organization so that as you create goals and as you create processes, you can point to this culturally and use it to motivate your teams. So much of what I'm going to talk about today is going to be very process-oriented around the things and processes that you need to do. And so it's important to make sure that people in your teams are seeing that in light of the type of culture and type of organization that you want to build. So when I speak to the engineers at Braze, what I tell them that we need to do at our company is first and foremost, make sure that we are moving to best-in-class modern technologies and that we're upgrading all of our technologies and staying up to date. Now, this can involve us building our own technologies. For example, we've built our own design system in order to make sure that we've got a consistent look and feel to our product. We've built deployment tools that I'll share about in a few slides. Or it may mean that we're trying to make sure that we're using modern systems, whether that's KSQL DB for high volume scalability, whether that's moving to AWS Aurora or looking at AWS DynamoDB for certain use cases. I want folks to feel that they can use the kind of best-in-class, just FANG-like technologies that exist out in the world. Also want to make sure that at Braze, we're doing whatever technology process and architecture changes we need to do to enable teams to be highly autonomous, productive. Teams ought to be able to independently test, deploy, monitor, support, and experiment with their own stacks and systems. They need to be able to handle pages. They need to be able to reason about their code independently. And getting to that is an important milestone for public company readiness because it allows you to continue to grow your organization once we've had 100 engineers or 200 engineers or more so. We also think always that what we're doing is to make Braze a highly available system that can be relied upon for business-critical experiences. I said that we're an enterprise SaaS organization, but I try to encourage our teams to think about our technology more like an infrastructure as a service, that our customers rely on us, and if we are down, that affects their relationship with their consumers. If you order a pizza from Pizza Hut and we don't send that order confirmation, You might think that they didn't get your order. You could be hungry, hangry, not knowing where your food is, blaming them when it could be our problem, and we could be hurting that brand relationship. Now, that's a trivial example, but there's a lot of examples around the customer experience that we help our customers with upsells, promotions, Super Bowl messages that are really timely and sensitive, and we have to treat our responsibility very seriously. And lastly, I think it's important that we have a world-class culture with high job satisfaction, that folks think Braze is a great place to be, that they can learn and grow themselves, take their seat at a table, and really just kind of work with great folks. So I always point back to these types of things whenever I'm introducing a new process, so that way folks can understand where it fits in. All right, let's kind of get now onto the talk about public company readiness. So these are kind of the way that I broke down those 4 themes that we'll get through. And as I mentioned, I want to start with reliability. Now, when your company goes public, that day is probably the biggest marketing day and marketing event your business will ever have had. You'll be written up in all sorts of newspapers. People will be talking about you. Businesses that may have never heard about you will now have you on your radar because you're not an obscure private business. You'll start to have financial analysts cover your stock, your industry, your business, and how you fit into the world and the ecosystem. And because of that, you can really risk your company's reputation if your product is not reliable. And you can feel free to tweet that if Twitter is up right now. So, when we looked in 2019 around thinking about how we can be on this path to reliability, these were the kinds of different pillars that we set in place that we've worked on the last few years. The first is getting to a 24/7 team on-call. This is important for us to ensure that we can provide enterprise-grade service level agreements, or SLAs, to our customers. So we started off with probably how a lot of companies evolve, where you just have a bunch of folks who know the system, they've worked on a lot of the code, who if there's a problem, they're the ones you go to. But we knew that this wouldn't scale, and that we would eventually need to go to team-based on-call. Because when you think about an engineering organization as it grows, we split into more teams. We have 27 engineering teams at Braze, and so there's a lot of different services that they own, and we knew that each one of those teams would have to be responsible for their services. Now, a challenge that we faced was that we have a primarily monolithic application, and so it's kind of a bit hard to untangle who owns what in our code base. But we had to do it anyway. So in order to get to on-call, the first thing I did was focus on employee experience, understanding that this is something that is going to intrude on folks' lives. If you now need to go on call, you now need to work more. You might not be able to go out without taking your laptop. And so we want to make sure that people have a good experience doing so. What we did at Braze was we formed an on-call committee to meet weekly to ensure that folks could voice questions or issues that were coming up around on-call. We started with a small volunteer group of folks. We then paged them during business hours, slowly moved that to after hours, slowly expanded that to teams. We defined code owners in our entire code base. We have thousands of files in our code base, and we went through every single one of them and made sure that there was a team assigned to it. And then we started to decorate all of our alerts and monitors with that information. So every Datadog error that we get logged is decorated with the best known code owner so we can route information to those teams. All in all, it took us about 2 years from the start of wanting to have a 24/7 on-call process to one that we now feel incredibly happy with. And that is something that if you haven't put in place in your organization, if your on-call is still being done by a handful of folks who just happen to know the code base, I can't recommend highly enough, get a process going now to make sure that you federate out the responsibility for uptime and incidents and pages to new engineers and team. In doing so, we had to define service level objectives for our service. Now, service level agreements are really important for your organization in any case, because your customers are going to want to guarantee that your service is online. But as a public company, you actually have to withhold revenue if you violate an SLA. Because if a customer can claim a credit and they're entitled to a rebate, you actually can't report that revenue to the street. So it actually becomes very important for you to make sure that you're going to adhere to your SLAs. And the difference between an SLA, a service level agreement, and an SLO, a service level objective, is the SLA is customer facing and the SLO is your internal target. And so we had to actually go through all of our services and say, what is the level of service that we're trying to provide? If we're going to process data in real time, what does real time mean? Is it 1 second, 10 seconds, 5 minutes, 15 minutes? If a customer sends a campaign to 1 million people, is that something that we are comfortable sending in 1 minute, 5 minutes, 10 minutes, 20 minutes? How many API calls per second should we allow a customer to make? And we have all of these different permutations of what is possible with our product. And we had to actually go through, and we're still doing this now, to make sure that we have an understanding of when we should page people, when we should wake people up, and what we should target our systems against. We also built out a formal incident response and triage program. So we hired an incident commander role, someone whose job is to be an incident commander when any kind of problem arises. We created other roles, like a communications liaison, to message internally or message to our customers. We had trained the entire organization where everyone at Braze now knows how to page an incident commander. We know when we should post to our status page. We now have a process for linking all of our support tickets that we get to a given incident. We can track our uptime, we report on it. And all of these processes, they had to be built. We started off just running them kind of by the seat of our pants, where a problem would happen, you'd call in the senior folks into a Slack room to resolve it, and maybe you write up an RCA. But now you have to get a lot more formal with these things because your customers demand it and your business demands it. And in that, we also instituted systematic reviews of any incidents that we had, and we made sure that teams are responsible for follow-ups. So at Braze, we have a daily page review of any page that happened to any team in the last 24 hours or on a Monday over the past weekend. And we make sure that that gets assigned to teams. And we have rules at Braze where if we essentially aim for 1 or less page per week per team. We think that's our baseline of what we say is acceptable. And if we see teams that start to trend up from that, we actually force them to stop their sprint work and make sure that they get back down to that baseline because we know it's not sustainable if they're getting more pages than that. It's going to affect their teams. We also get product managers involved such that they know and are held accountable to helping the reliability of the system. Because as many of you may know, tech debt versus the business needs, the business tends to win most of the time. But if we get the product managers and the business in the room and we talk about the impact, then we can help everyone kind of get on the same page and improve our system. So that was a great level of process, but I want to dig into some architecture as well, because reliability is not just around the process, it's about your architecture. So I'm going to go through a case study of an example of something that we had to build and how we use AWS to achieve high availability and a reliable system. And with each of the examples I'll go through in this talk, I'll also talk both about process and then dig into architecture. So I'll talk to you a bit about what we refer to as our SMS backup endpoint. So as I mentioned, we send SMS messages on behalf of customers. For example, if you got a text from Pizza Hut today or Friday for something that came from Braze. And SMS is a very particular channel because it's subject to telecommunications laws. If a consumer replies stop or opt out, you have to honor that. And if you still send a message to someone after they've opted out, you can be fined up to $500 per message per recipient that you send them after they have opted out. So we really have to make sure that if someone opts out, we get that message. Now, we rely on providers to receive inbound SMS because we're not hooked into the telephony system. Twilio is, or Infobip is. So if folks in the room use Twilio, or Infobip, the way they work is when a customer texts back the number, they just webhook it over to you. But they don't actually have the most reliable retry mechanisms. So the way that Twilio works, for example, is they'll webhook the response to you, and if it fails, they let you specify a secondary place where they'll webhook it to, and if that fails, they just drop it. So back in June of 2021, Fastly had a really bad global outage, and we had our APIs behind Fastly. So our primary endpoint and our secondary endpoint went down. We lost the messages. It exposed us to a lot of risk, and that was something that we said we just couldn't abide by. So we said we have to build a system now that is completely reliable, that isn't going to depend on, say, Fastly or Cloudflare or any other kind of CDN front, and make sure that we can now not ever miss webhooks that come to us with respect to SMS messages. So the way that we did that is we used regional DNS routing with AWS Route 53. So if Twilio isn't going to retry, we figure, well, we can build a system that does. So we're going to build a really, really simple system. It's essentially just going to have a load balancer, a HTTP service, ingest the payload, log that payload to Kafka, and then we can have a Kafka topic consumer that's just going to read that and replay those events back to our own system. And what's really nice is that AWS Route 53 has health check-based load balancing. So we built one of these in US East 1 in Virginia and in EU Central 1 in Frankfurt. And so now, if our primary system is down, the secondary endpoint will hit one of these two regions, and if there's an issue going on in, say, US East 1, it'll fail over and hit the EU region. And then we can just simply replay those messages. And we isolated this infrastructure entirely on AWS, so it's not behind Fast2, Cloudflare. Everything is now just 100% AWS. And it's also on a different system than our primary systems. And so this is just an example of the way in which you need to think about all of your services. How can they become more fault tolerant? How can you become highly available and reliable for things you absolutely have to run during your day-to-day? So I said earlier that there's a lot of reputational risk and reliability, and that is doubly true for security. Because our customers trust us with their most important asset, which is their customer relationships as well as their customers' data. So we want to meet and exceed their expectations in today's modern computing world. So what's table stakes for security is that you have an ISO 27001 certification and that you undergo annual SOC 2 Type 2 audits. So if you're looking to increase your company's reputation or bolster your security practices, I strongly say start with ISO 27001 or SOC 2 Type 2 and make sure that you're able to complete these audits and pass these types of things, because it'll walk you through setting up an information security management system that is industry standard and processes internally that you're going to make sure that you can comply with essentially modern security requirements. So we built a security team at Braze. We have 7 folks in it, and they focus on a couple of different areas. One is application security. So we've hired people who are essentially white hat hackers who will try to pen test all of Braze's internal systems. Every time we build new functionality, they come in and try to essentially hack it. We have infrastructure security engineers. These work with our DevOps teams to define what we call the Braze AWS foundational standards around what we're going to put in place for AWS. These are things like ensuring that all EBS drives are encrypted, that any account that hasn't logged in 45 days is deactivated, that we have CloudTrail set up for all regions, that we monitor and record all changes to ingress rules, and those are sent to the team. We have no star.star permissions and IAM roles. Those kinds of just security best practices. Everyone is 2FA enabled. You need to actually put those in place and monitor them and be able to have controls around the adherence to that. And so we have someone whose job is to make that the case. We have network security engineers who focus on our edge network and are doing scanning there, as well as then folks around governance, risk, and compliance to focus around our internal audits and working with customers to help them understand our security posture. In addition to this, we undergo annual tabletop exercises for crisis management. This is something that we require to do under ISO 27001. And so we run simulations of what happens if Braze is hacked because an AWS IAM key is exposed. Or we ran a simulation this year which was exciting around financial fraud, that someone was phished and it was someone on our finance team. And so these are really exciting exercises. We bring our general counsel, our CFO, DevOps organizations, product engineers, we get together and we run this exercise over the course of a few hours. And then we feel more confident about our ability to respond. So from an infrastructure, that's the process kind of side. Now I want to talk about the infrastructure use case. And I want to walk through how we do our bug bounty, because I think it's actually pretty cool. So as part of our public company readiness plan, we decided that we wanted to build a public bug bounty program. Right? We want to make sure that Braze doesn't have any vulnerabilities that we're aware of, and that we find them before an attacker does. So what we did is we wanted to start with a private program that we'd eventually get to a public program that anyone on BugCrowd, which is the platform we chose, could sign up and start testing and researching against vulnerabilities for Braze. So the first thing that we did was we did a 2-week-long on-demand program with BugCrowd in order to just get a baseline. We said, let's take 50 researchers that we invited to the program, give them 2 weeks, see what they can find. And they actually tested against our staging environment. And the challenging thing for us was it was very hard to then do this, to scale out to 50 researchers testing our staging environment. We had to create logins for all of them. We actually gave them each 2 logins, so that way they could try to privilege escalate between them. So we had to create 100 new accounts, give it to them, track things. The scalability of our testing infrastructure was challenging. And I don't mean it from like a technical scalability of can we handle the request, just of like how do we manage all these new accounts and see what folks are doing and make sure that they're not breaking our staging environment for our internal usages. And so what we did was we built out and relied on something that we call our platform custom environments. And these, I think, are really cool things that help us a lot at Braze that we rely upon with our development. So what a platform custom environment is it's a fully functioning, isolated instance of the Braze platform and all of its supporting infrastructure that we've built and deployed on Kubernetes. So this includes a web dashboard, all of our public-facing APIs, our databases. So it's got Redis, it's got Mongo, it's got Postgres, it's got Memcache, it's got Kafka in there. It's got all sorts of different services there. And what we have this platform custom environment for is primarily the goal was to help our developers do better testing. We wanted folks to be able to test out user acceptance testing with designers on the things that they're building, or trial things out to customers. Or we wanted to be able to run end-to-end tests on environments, on feature branches, to make sure that we weren't breaking anything when we ran Cypress front-end tests. So we built these platform custom environments and realized we could use this for our bug bounty as well. So we'll just kind of chat through how this works. So essentially, our platform custom environment is governed by two workflows. One is essentially the database seed stage, and we use MongoDB as our primary database for setting up a dashboard account with the configuration and projects there. And then a deployment workflow to actually deploy the services. So I'll kind of walk through a diagram of what these steps are. But essentially what you can think about is we want to take a bunch of fake data and our staging data and have that, or we can repeat that and give that to different environments. And then we want to make sure that we can deploy dashboards, API servers, databases, and allow folks to operate on them. So if I kind of look at how this works, every week we build and seed a new MongoDB image. This takes about 90 minutes to do. That's why we do it only once a week. And what we want to do is we've got some scripts that can generate fake data, and we want to take a dump of our staging environment and have that available so that we've kind of got a pretty up-to-date version of testing data. So first we trigger a build kite job. We're going to create a Mongo dump off of our staging environment. We're going to have an empty database. We'll have an image for that. We'll push that up to Artifactory. And then we'll deploy that image to Kubernetes, attach an EBS volume as a persistent volume, and then run a Mongo restore in order to load the data to the database. Once we have that completed after that, say, 60 to 90-minute process, we extract the volume ID and create an EBS snapshot. And it's that EBS snapshot that's the basis for all other PCEs that get deployed over the course of the next week. So every week, we're going to have the latest MongoDB data. From there, the kind of top left part of this diagram is the previous workflow. We'll create an EBS volume from that snapshot, so make sure we have a MongoDB database. And then we can build an image off of our platform monolith code base off of a feature branch that a developer that they supply. And then we can deploy all of the things that run our platform. And what's cool about deploying these things on Kubernetes is we have a Helm chart for each of our services. And so we essentially create like one big Helm chart that lists dependencies of all the other Helm charts. And you got this really big application that all of a sudden you can deploy dozens of services together. So this is a screenshot of our PCE deployment management service. There's a piece of cake up there because our goal was to make this as a piece of cake for testing environments. So we've got is you can create a branch name. You see who creates it. There's URLs for it, for the dashboard, for the APIs, for all of the other services there. We hook this up to APM and Datadog, so anyone who builds a custom environment can analyze what's going on and filter their environment out in Datadog. We have logs that they can look at as well. We have the links to all the pods and containers, so you can inspect those in Datadog or understand what kubectl commands to run in order to analyze this. And this was something that we built internally. Again, looking at this back to part of our culture. How do we build modern, cutting-edge software? How do we make sure that folks are able to independently test, deploy, and operate and experiment with and validate their environments? These are the types of things that we can point back to that cultural vision and say, we're doing this stuff for the ability for us to move faster. And what was nice about this is we could kill two birds with one stone, because once we had this, we could use this for our bug bounty. And so now we use this exact same thing for our bug bounty, and every week they get the latest version of code, and we don't have to sacrifice our staging environment for it at all. So this is a really cool way for us to kill two birds with one stone, both testing developer changes as well as providing an environment for folks to test. So now, if you're a security researcher, you can go to bugcrowd.com and sign up for Braze's bug bounty and begin hacking. So moving away from reliability and security, another important part of public company readiness is all around financials. So what I've got here is descriptions of core forecasting. Core stands for cost of revenue. Accurate budgeting is extremely important as a public company. Our goal at Braze, and we try to set goals for all the things, like no more than 1 page per week per team. For forecasting, we say we want to be within 5% of what we forecasted. And if we're not within 5%, then we think that there's something wrong, and we've got to kind of figure out why we weren't within 5%. But if we forecast that it's going to be $1,000 and it comes in at $1,500, that's bad. But if it comes in at $1,025, it's fine. So we essentially treat that as within forecast. So this is challenging to do, and if anyone has ever had to kind of say how much it's going to cost to build the thing they want to build, you know that there's kind of a lot of art that goes into this science. So we can use AWS technologies to help us do that. So I'm kind of want to describe how this works at a high level and dig into an example of how we actually use this cost tagging at Braze. So what we do is we have a cost center tag that we apply to every single resource that gets created, and this is controlled through Terraform. So we can apply if something is R&D, something is from marketing. We have environments, so we know if it's staging or production. And we also eventually want to get to team-based costs and tagging those. But as I said, everything that gets created in AWS is going to have a cost tag. And then we have built a Golang tool to take all of our resources from AWS and share the ones that don't have tags, so we can periodically do audits to see if somehow someone created something in Terraform they didn't put a cost tag on. And for Kubernetes, where tagging is harder to do, we use labels around our deployments, and so that way we can break it down. So using the combination of Datadog, AWS Cost Explorer, and VMware Cloud Health, and KubeCost, so 4 tools, we're able to go through and try to look at all of the costs that we have for each part of our infrastructure. And we also look at costs on a monthly basis. So we have a monthly cost review meeting, where we go through and we look at all of our AWS costs. We look at our savings plans. We also have targets for those, so we try to gear toward 90% savings plan coverage. And we try to make sense of our costs every single month and make sure that things are in line with where we think they would be. We also have implemented a core committee to go in every single month and talk about projects that we could be running in order to improve our costs. So we want to just talk about what are the things that we may have on the docket of optimizations that we want to make that we think will save compute costs or improve database costs, or what things do we have up there that we can just kind of keep our finance team abreast of what we're thinking about from a cost perspective. Because margin is extremely important to your business. It can really make or break how much expense you have to fund your business, and also it is vital to your path to profitability. So we'll talk through how this is put together in practice. And the case study I want to talk through is how we tag our cost per customer, and also just how our system works in general. So there's 2 main categories of processing at Braze. You can think about it as data processing and message sending. Data processing is essentially the data that comes in from our customers, and we want to make sure that we need to act on that. If you make a purchase on a website, we receive that purchase, and then what do we do with that? Do we trigger a message? Do we cancel a message? Do we treat you as converting off of a promotional campaign or whatnot? And then there's the message sending. So that could be messages that are sent by customer action, like when a purchase is made. Could be canceling messages to be sent because, say, you did make a purchase and now we don't want to send that follow-up nudge because you actually already converted. Could be a scheduled message that someone wants to send out. So lots of different messages that we send at Braze. And so we've got these 2 different types of processing. And then we think about putting our customers on a couple of different database orientations. So we deploy our customers to a few different models of our databases. And this is really geared around essentially how much resourcing we want to give to our customers. If you are Disney Plus you have a lot of users and need a lot of resources and send messages. If you're a very small mobile app that has only 10,000 users, you probably don't need as many resources. And so we want to make sure that we're always right-sizing our customers to the amount of resources that they need. And for us, it starts at the database layer. So we can either put customers on their own dedicated databases, or we can share them in some of our shared multi-tenant databases. But ultimately then how our system works is we operate on a system of job queues. Whenever data comes in, we put it in a queue to process. If messages need to be sent, we put those in queues for us to go out. First in, first out queues is pretty standard. Each database has a port. So say you've got port 12345, and you've got port 7890. Those are two different databases. We then build data processing and message sending worker fleets that are tied to those databases. So there'll be message sending servers that send messages for port 12345, or data processing workers that process data for port 67890. And then we tag all of these. So the EC2 servers that are running for port 12345 are tagged with port 12345. The database is tagged with port 12345. And so now we can look at and say how much we're spending for a particular cluster or a particular customer off of our EC2 servers and our databases. Now we use queuing, but we've got a really cool blog post on our site that talks about how we built a dynamic queuing system to ensure that we don't starve out processing. We make sure that even though we're first in, first out, we're processing in parallel as much as we can. That is another talk in its own. But all of this is generally geared around tagging the customer's port. So then when we have that, the way that we scale is in the EC2 world, there's an auto scale group for each database port per availability zone per worker type. So if I'm a data processing worker for port 12345, we have 3 availability zones for that: US East 1A, 1C, and 1D. And so each database port essentially gets 6 auto-scale groups, and they're all controlled through Terraform, so it's easy for us to create these. You get 3 for data processing, 3 for message sending. And then we have a process that runs and is reporting metrics to AWS CloudWatch. It reports back things like how many jobs are in queue, what's the latency of those, meaning jobs that are in queue, how long have they been in queue for. We have load forecasting around how much work we think we're going to do, say on the hour or some other timeline. And we log this to AWS CloudWatch to be used by AWS Lambda. Now, a reason we use CloudWatch is because it has read after write consistency, and it can be guaranteed to be accurate. We log these metrics to Datadog as well, but we can't necessarily rely on them. They could be a few minutes delayed. With AWS CloudWatch, they have really strong guarantees around the real-time nature and processing of these. So what we have is we have a Lambda that runs then for every single port and for every single worker type. And that runs every 2 minutes. It reads the AWS CloudWatch metrics. It does some math, and it determines how many servers should scale up. And then it takes the auto-scale group and it sets the amount of desired capacity and scales this up and down all throughout the day. So we cycle through thousands of different servers all automatically through auto-scale processes to ensure that we can then tie this back to a service level that we define back in on-call committee. Because we page teams if we have a poor quality of service, we can then have this as a function that we can continue to modify to make sure that if there's any kind of incident, we can then put this back in our Lambda scripts and make sure that we're automatically scaling up and not having to page folks. So this is a really important part of our feedback loop to make sure that we're delivering a great quality of service. So in the Kubernetes world, this is kind of a diagram of what I just described. In Kubernetes, we can scale much more faster with much more granularity. But generally, this is maybe a bit hard to kind of look through. This essentially shows that we're collecting metrics. We are then making a determination of what's the rate of change. Do we need to scale up? Do we need to scale down? And passing those through to different scaling functions, whether that is auto-scale groups or in kubectl, we can set the number of pods that we have there. So we're actually partway through moving our whole system off EC2 onto Kubernetes, and that's going to help us with our granularity of scaling and also scale faster. And we measure the costs of all of this because of tags and because of Kubernetes labels. So we can look at each individual customer, an estimated cost of how much they are costing us. And this is really valuable for margin calculation because then we share this data back to our revenue operations team. When we go through renewals, we can make sure that we're not underwater and that we have a great underwater is not even the goal. I mean, it's high margins in software to make sure that we are really delivering the service at the right cost to the customer. So I'm going to continue a bit with this kind of cost modeling here and talk a bit about entitlements and audits. So if you're not an enterprise SaaS company, if you don't have a lot of SKUs to sell, if people just kind of put your credit card in and that's it, this may be less of an issue for you. But entitlements and audits were a big part of what we had to focus on when we were becoming public company ready. The general question that you have to ask yourself is, how strongly can you defend every cent of revenue that you have? And you have to build a process that can track, for us, the billions of pieces of data that we process, all the messages that we send, all the associated overages, like email and SMS or CPM-based channels, that we can track all of that and defend why we charge the customer, why we charge them, and why we booked revenue when we charged. Now, this is challenging to do because of the amount of precision and accuracy that you actually have to have as a public company. Before public company readiness, the way that we did this is we just kind of roll up our data and keep it in aggregate form. But that doesn't really work in the Sarbanes-Oxley world where we have to describe exactly why we built someone and what happened. So it's really important for you to focus on making sure that if you're going to charge someone any amount of money, you can tie that back to their usage. And I'll kind of walk you through in a minute how we've built systems to do that. Another thing that public companies are required to do under Sarbanes-Oxley is auditing of permissions, roles, and kind of who has access to what. So if you're not already auditing internal access, that's something you just got to do. I mean, you got to look at everyone who has admin access on GitHub because they could change your code, and that could affect your revenue. Everyone who has access to any kind of internal tooling that you've got to view customers' accounts, and you need to make sure on a quarterly basis at least that they are allowed to have that access based on their role. And it's super important to put those processes in place because the longer you go without them, the more work you have to do to maybe build that into your internal tooling. And lastly, we also had to build a great capitalization process to track engineering time spent on projects. So what capitalization allows you to do is take engineering compensation and amortize that R&D expense out of your operating expense line. And this is something that requires a lot of process tracking and will actually change the way that your teams track their own projects. So it's kind of important to get started on that stuff early. So if I kind of look at the diagram I showed you at the very beginning, I kind of highlighted the bottom left corner of it, which is a big focus on our new billing system that we built in order to be public company ready. We wanted to, again, make sure that we had accurate, non-aggregated data for anything that we build on. So what we did is we built a pipeline of everything that came into our system to go to Snowflake, and that we could store trillions of rows of data for every single thing that could construe a billing event. And as I mentioned before, we would aggregate this data, and then we'd have it available in its aggregate form, but that wasn't good enough. We needed to also have the source of where it came from. So we started including the source. Did a customer send this from a mobile app? Did it come from an API call? Did they upload it from a CSV on our dashboard? Did it come from their Shopify store? We needed to make sure we tracked the provenance of all of this. So when a customer said, hey, why did you bill me for all this processing? We could say, hey, well, this is what happened, and we could actually defend that to them and to an auditor. And what's nice about this too is then now that we had Snowflake to centralize our billing data, we started pulling our Salesforce data into this as well, so we could look at entitlements and pacing and understand if a customer is pacing ahead of their contract and be able to reach out to them proactively. So it also had good benefits for sales. And this was something that we had to do in engineering to make sure that we all felt very good about our billing. So if you kind of look at how this works, this is a kind of a zoomed in version of that bottom left corner. If data comes into Braze, say in this example I've got it coming in from a mobile device, comes to our API server, it goes into our job queue, is processed by a data processing server that I've talked about, that then logs to Kafka. We then use Kafka streams to put that into a topic, Kafka Connect to put that into an S3 bucket, and then we snowpipe that directly into Snowflake. And so this is a reliable process that we've set up in order to make sure that everything that comes into Braze is then ultimately available in Snowflake. Now, the last topic that I want to talk about on public company readiness is modularity. And this is really part of that engineering culture I talked about earlier, which is that how can you enable teams to be independent owners? The way I look at it is, as we hire more engineers, I want to make sure we're moving faster. If we have 100 engineers, I want 100 engineers of output. If we have 200 engineers, I want 200 engineers of output. And you know how hard it is to do that. I mean, there's laws that say you make a late software project later by adding more engineers to it. You got to fight back against that kind of thing. So it was important for us to focus on excellent tooling. Again, teams should be able to independently own, test, deploy, provide support for, and build their own systems. And so we've done a number of infrastructure enhancements in order to get ready to continue to scale our own organization. So I want to talk to you about some of those today. Now, one of them was building a deployment tool. So for our major applications, we now have a great tool that allows us to easily test, deploy, run canaries, and roll back our code. We've got a screenshot of what this looks like here on the right. We can see what version of a code base is deployed where, what percent it's rolled out to. We can make it easy for our teams to opt in to doing deploys. So we actually now have all sorts of GitHub operations where you can add a GitHub comment on a branch. It'll go into the next day's daily release, and then that will all go out to make it just easy for you to opt into getting your code out to production. This also is important for our more formal release management processes. Just like we hired an incident commander for managing any kind of incident that comes in, we have release manager responsibilities around our release to make sure that they're de-risked. And the release manager can easily see the status on what is where, at what percentage, whose commits were out there. If there's any kind of issue, we can do diffs and understand who contributed to the difference in code that went out in each daily release. Another thing that we did was make sure that we had an audit of all of our configuration changes. Before being a public company, we were actually doing all of our secrets management through encrypted Chef data bags. And as we've been moving to Kubernetes, that's not something we could do anymore. And the problem with encrypted Chef data bags is there's no version control. And we've had issues due to human error where someone fat fingers a password change or something like that, or just in general required manual intervention. We couldn't kind of simultaneously roll out a config change along with a code deploy. It became problematic for us. And so we decided we needed to move to a more modern model. And we moved to is called SOPs. It stands for Secret Operations. It's something built by Mozilla. And it is now a GitHub repository of all of our secrets, and it's encrypted. So every engineer that comes to Braze will create an IAM user in AWS, and then they can modify configuration. And then when configuration is changed, there's a pull request that goes out, gets approved by teams, gets merged in. We have Jenkins jobs that then will be kicked off and create a new configuration artifact that's uploaded to Artifactory. And then on every server deploy from the previous screen, it orchestrates out updating configuration and updating the code package there. So there's a whole bunch of stuff that I talked about in here, and we're going to get to Q&A. I think we have maybe 7 or 8 minutes for Q&A. But really, the big takeaways are that those topics of reliability, security, operational efficiency, entitlements, audits, billing, these are really important for you to focus on your path to being a public company. I know I talked a lot about process here, but that's really what this stuff is. You have to have good process at your company to scale. So the big takeaways I've got is you've got to be reliable. You have to make sure that folks can't point to you and say you had a big outage and no one can trust you. You've got to make sure that you've got security that your clients can expect and that you're earning their trust, that you're forecasting your costs effectively, you're defending all the revenue that you're booking, and that you're making your teams as efficient as possible and continuing to improve all of your interfaces. So with that, we can kind of hop into Q&A, and I hope you enjoy the talk.